earlier, like now we are Java 1.8, 1.9, right? So when we have 1.5, what used to happen is when you want to add an integer, an int into an array list data structure, any data structure, what used to happen is, as you cannot keep the int primitive data type into the array list data, any data structures, we need to convert that into integer object using wrapper classes and keep it into the data structure. Until then it's perfectly fine. Next thing is, when you try to extract, right, as you kept integer object, not int, right, as you kept integer object inside the data structure, then when you try to extract, you need to take it as an integer, and then you need to convert into explicitly an int, right? There are two steps involved. So when you're extracting, first you need to get it as an integer object, as you kept integer object, and then get it as convert into int by using integer dot int value, right? So this two-step process is like little, very annoying. So Java comes up with the concept of auto boxing, auto unboxing, which means let me, so this is the, let's say, data structure. Okay, any kind of data structure. You have a equal to 10. Okay, first you try to keep this one, it doesn't allow, basic rule, right? But as data structures doesn't accept a primitive data type, so what you do, you convert into integer array, integer object, right? You convert into integer object and keep it inside, right? Integer object of 10 will be stored in this data structure. So you added one step, first converting into integer object and then keeping into the data structure. Now try to extract it. When you try to extract it, you get integer object, but you need what? Integer data type, integer primitive data type. So again you need to convert back. Second step, int object, int primitive data type, right? So this step and this step, rather than giving the developer to explicitly convert it every time, Java comes up with a concept auto boxing and auto unboxing. Auto boxing is when you try to keep that value inside a 10, it automatically converts into integer object inside Java itself, converts into an integer object and keep it here. You don't need to do this step. Okay, when you try to extract this object, it automatically convert that value into int data primitive type and give it back, so you don't need to do this step. So this is unboxing, this is auto boxing. Auto boxing is auto unboxing. Holy cow, why it is coming again? Why the hell? Let's go to collections now. So all we're waiting, right? So java dot util dot list. Give me 1 second. Yeah, it didn't cover. Okay. Where is the best place to take it? I think I will go to my document, okay? So we can easily discuss. Mm, it takes a couple of minutes. No. Okay. And last chance. I'll just go to my old hash. Yeah, all I want is this diagram. Okay, you guys able to see, right? So in collection package is in all the data types are in java.util package. Okay, in java.util package. Okay, so in that basically why collections. Okay, so the first and foremost thing is we have one thing we learned as of now is one type of one type of bucket that can hold of your data, like that it's a kind of a box or bucket which can hold multiple data, like multiple objects, multiple strings or multiple int or whatever it is, right? That is nothing but array. Okay, so array has certain limitations. What is the limitation? Basically, array cannot grow automatically, right? And array need to be initialized with size while while initializing itself you need to provide the size of an array, which means initially you thought your array is going to be of size 10 and you defined your array with 10, but when you are when you are collecting the data into that array you end up with identifying the size of an array is more than 10. So it started failing, so you need to go back and correct your program. And again you thought like you increase size of the array with 15 and later when the process you end up identifying the data is 20. So again your program breaks, you need to go back and correct it. So the major drawback is arrays cannot grow, and you need to initialize in the beginning of the while, I mean, you need to initialize an array with size, right? Otherwise you cannot create an array. So that is one of the, those are the shortcomings. Along with that, Java, when they are building collections, they kind of thought when you are writing your business logic, when they are using in some developer or some big company using Java technology, what are the challenges they will encounter, right? And see if we can address. So with that keeping in mind, the important piece is like always keeping the data together, always keeping the multiple objects together, and playing around the objects is very important. So let's provide them a set of data structures, a set of data structures, and provide them some functionality for each data structure. Give them some functionality, and give some operations around those functionalities, and make use of it. So this is what Java thought and started, in the beginning itself introduced with this collection objects, data structures. These the mentioned so-called listed here, right? All the data structures. You can call it a data structures or collections, okay? So they kept all these things in the one package called java.util, okay? And then they provided, now the list has been increased. This is the old document, but it's a pretty good enough document to start, okay? Interfaces, they kept collect such an, some certain set of interfaces, and then a set of classes, okay? So these are the important, no matter what, you need to remember, okay? You need to remember in the sense, you need to get the sense when you heard about map, what it does, what kind of collection it is, what kind of data structure it is. When somebody said like HashSet, oh, who is the parent of HashSet, and what kind of behavior it, what is the definition of HashSet, how it behaves when I keep an object inside, does it have any special treatment inside, like does it do any operations when you try to keep an object inside. So these are all things that should come into mind at least, okay? So having said that, give me 1 second. So how they laid out the structure, okay? So basically they have, see, collection, list, set, map, sorted map, iterator, list iterator, enumeration. These are all the interfaces in collections family. These are all the um, what happened? Interfaces in collection family, okay? And ArrayList, vector, linked list, HashSet, TreeSet, linked HashSet, HashMap, TreeMap, hash table, linked HashMap, collections. This is collection, this is collections, okay? These are all classes. These are all different classes in collection family, okay? So collection family or collection framework, whatever you call it, okay? So here the highlighted the structure here, right? Everything falls into collection framework, but the above ones will fall into collection family, okay? This everything fall into collection framework, and this one, the list, set, all this falls into collection, okay? Collection is in what? Interface. So it has been having divided into two parts. By, basically collection has some behavior, and let's say collection has some behavior. Collection is one type of data structure, some behavior, and they thought simply providing collection may not be helpful. Let's provide, some behavior and segregate them, okay? One is list, again an interface, and then set, an interface. Okay, then they started providing some functionalities, different functionalities here. Okay, array list implementations. Okay, list implementations, what are the different type of list implementations that you know of? Okay, one is array list, vector, linked list. Okay, these are the different implementations that has been given from the list family, from list interface. Okay, and for set HashSet, TreeSet, sorted set will be there, right? Linked HashSet, linked HashSet, and then first sorted set, and then in that you have TreeSet. So these are the three different implementations has been given from set family. For TreeSet, there is another interface also, parent. They introduced another parent called sorted set because they want to do some functionality especially for TreeSet. Okay, this is one section. Okay, another section is a map. This is an interface which is having HashMap, hash, what you call the hash table, linked hash table, and the same thing, sorted map, and this guy is having TreeMap. Okay, this is an interface, this is an interface, this is the class, this is an implementation class, this is an implementation class, this is an implementation class. Okay, got it. So that's how it has been divided. Like I mentioned, all are going to hold the an objects. It's kind, all are going to act as a bucket. Okay, but when you keep in array list bucket, your data will be in some way, and when you try to keep the same data, same objects into tree set or hash set, you will have some different functionality. Okay, why they provided different functionalities? They kind of thought each and every day an engineer or Java developer going to use these functionalities, and rather than developer implementing every time in each company, let's provide these common functionalities so that the developer can start using them. Okay, that's all. Whatever the building functionality that has been given by Java, there has to be some meaning, and we need to use for if we learn more about the built-in functionality inside Java, the better you can use. Rather than reinventing the wheel, we can use the existing functionality and play around. Okay. So having said that, let's jump into this piece, collections. Okay, we'll do the program, but let's talk about a little bit of the terminologies and concepts. Okay? So list is a collection of objects. An object can be a student object, employee object, an integer, a string or float, car objects, vehicle objects, anything, right? A list is a collection of objects. List allows duplicates. List allows duplicates. And set is a collection of objects. Set doesn't allow duplicates. So by reading these four statements, what we understand, when you are keeping inside list, if you doesn't care about the duplicate values, then it's better to go for list. When you really want somebody should not, unique values in your collection objects, okay, then you need to go for set. Okay, so and the last one is map. What is map? Map is a collection of key value pairs. So I'm not going in detail, we just read out a couple of theory concepts and go to the programs. That would be good best. Okay, what they are saying is, if you say a list, it's a collection of objects. Okay, and if you keep Shiva here, Prasad, again Shiva, Santosh, Kumar. If you keep like this and you don't worry about the same objects getting inserted again and again, you can go for list family. Or else, if you have a concerns, you don't want this duplicate to be entered, then you need to go for set family. Okay, set is smart enough to detect the duplicate. How we need to see, we'll discuss, we'll do the program. Smart enough to detect this duplicate and not allow it, just override the existing one or just leave it, ignore this insertion. That is a set behavior, basic behavior. Okay, there are some more differences we will see. And then map is not simple collection, it's a collection is like key value pair. Map is a concept or a data type which will take key value, which means you can keep ID here, like say student object. Here you used to keep the student object. Okay, ID student object. This is Shiva student object with name, salary, student, course, all the blah 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 stuff. And here you keep the ID 1. A student ID is 1, this student ID is 10, some student object here, student ID is 21, some student object here. Okay, this is a key value pair. Okay, map is a collection of key value pair. Okay. So what is, like we talked about it, now these are like, at least we understand for now, there are different interfaces available, there are different classes available for collection family, for data structures, to address the, to allow to hold the multiple objects together, right? So, and each one has their own implementations, right? What are the implementations? What are the definitions? You remember, if when you are writing, you remember that interface concept when we're talking about, like I'll say just a vehicle. It's a specification, right? It's just a specification. It doesn't provide any implementation. Whoever want it, they're going to provide an implementation, vehicle, for a vehicle implementation, whoever implements. So same thing here. Collection is an interface which has some specifications, like whenever somebody is using this collection, they should implement the method called size. They should implement the method called isEmpty. They should implement the method called contains. They should implement the iterator, toArray, add, remove, contains all, add all, remove all, retain all. These are all the methods they need to implement. Okay. So, like I said, collection is the super parent of collection framework. List is also an interface, collection also an interface. So list is going to implement collection, right? Sorry, list is going to extend an interface. If an interface want to extend another interface, if the interface want to get the functionality of another interface, then they need to go for extends, right? If a class want to get the functionality of an interface, then you need to go implements. So list extends collection. Okay, list is extending the collection, and this have some functionality. These are all the get, set, add, remove, index of, last index of, literate, iterator, sublist. So sense it, right? Whatever it is there in the collection specification, collection definition, size, all these things will be given to both list and set, right? Because it has set and list, both are extending collections interface. But the methods that has been there inside the list will be allowed, will be given to only ArrayList, vector, linked list. These are the only three things, three data types going to implement the list functionality. What are the list functionalities? Get, set, add, remove, index of, last index of, list iterator, sublist. Getting my point? These functionalities you won't get it in set family because they are implemented by list family. Okay. Next one is public interface set extends collection. So set doesn't have any additional functionalities apart from collection block, apart from collection, whatever the methods that has been specifications that has been there in the collection, apart from it doesn't have anything unique. Okay, they just extending into set extends implements by HashSet, linked HashSet, TreeSet, sorted HashSet. Okay, and that is up to this level, collection, list, set. Okay, now list is going to be implemented by ArrayList, and ArrayList is going need to implement all the methods that has been there in the list. Along with that, it can have its own functionality as well, right? So in those lines, see, class ArrayList extends some abstract list, implements list, random access, clonable, serializable. We haven't talked about serializable, clonable, that's okay. So basically it is implements list, and then it has its own constructors: array list of int, array list of collection, void.trim size, ensure capacity, remove range. These are all the additional implementations inside ArrayList which are not there as part of list. Okay, so basically we try to understand collection, list, ArrayList, this section. Okay, then we'll come back to collection, list, linked list, and collection set, HashSet, collection set, TreeSet. Okay, like that. So basically what happens, what happens when you create an array list, right? So when you create a list or array list, initially it goes with some size, default size. Okay, some formula will be there, what is the size it's supposed to go, and let's say it started with size 5. Okay, when you create an array list, then it started a size of 5, and then you started inserting elements 1, 3, 9, 6, 10, and you try to insert 11. In array concept, it used to break array index out of bound, but here what happens, if you try to insert a new value where you don't have, array doesn't have index, what it will do, it will double the size, like another set. So you can insert 30, 40, 50, 60, 90, and if it becomes, again increases, automatically increase the size. The capacity of the array list can grow automatically as and when it reaches certain extent. Okay, so let's do a simple example. I will stretch in the beginning a lot, and I will skip a topic because each and every element covering is difficult, but for the beginning ones I'll go in detail so that you will be confident enough to understand remaining pieces. what we'll do, generally, let's say, what I'm trying to say is int and of size an array, okay, new int of 5. You need to initialize must, right, in the beginning for array. That is one disadvantage. Okay, and then as and when you keep the values 0 equal to explicitly, you need to add like this, right? Array of 1 equal to 13. So here you will get an exception called, you will get an exception because you are trying to insert in an array of size 5, you are trying to insert an array, sixth element where your array size is 5. So if you want to correct it, you want to come back and fix the program. Later, if you want to insert some other element, again it fails, you need to increase, come back and increase, right? This is the biggest disadvantage of array. Logically, inside ArrayList also internally uses the array concept, but it's an abstract to us. It just uses the same thing, like, when it starts, it will start with an array. When ArrayList starts, it starts with an array, and as and when size increases, it will copies into the new array with the big size. Okay, so here, so the basic differences: collection family versus array. Arrays are not resizable, provides a lot of useful data types, and resizable dynamically. Collection family: array list, linked asset, linked list, TreeSet, all these are collections, right? Arrays doesn't allow generics. The generic concept that we discussed, right? It doesn't allow. Collections allow generics. Arrays will store both primitive and objects. Collections, like I said, doesn't store primitive data types, stores only objects. How can primitive data types can be stored into collections? Using auto boxing and unboxing. Okay, size and length of the array must be provided while initializing. Collections will be created by the default size. Okay, performance both will be same. Performance both will be same as ArrayList internally uses array, and each time when it reaches maximum, it needs to be created a new array and copy the data from the old array. Okay, here you must provide the length, same thing. Here ArrayList, like let's say one of the data type in the collections family is ArrayList. ArrayList initial size is 0 and initial capacity is 10. When it reaches maximum, it increases the size with new capacity using this formula. Okay, ArrayList initial size is 0 and initial capacity is 10. Capacity size different. Okay, you understand, or you need explanation there? The capacity and the size are different. Okay, in interview, if somebody want to go deeper into these lines, in one of the interview I encountered, they will ask, they'll just declare ArrayList AL equal to new ArrayList. So tell me the size of the ArrayList and tell me the capacity of the ArrayList. Size is as and when you keep the values, the size will be defined. Capacity is irrespective of whether you keeping the values inside the ArrayList or not, certain fixed capacity has been defined. Okay, so how ArrayList grows? So like I said, ArrayList internally act as an array, but let's say with the initial capacity of 10, size of 0. Okay, size forget about it, capacity with 10. Okay, and as and when it reaches maximum, like if you insert a 10th element, then it realizes I reached maximum. If he comes back with another element, I need to be ready with extra size. What it will do, it will use the math called old capacity into 3 divided by 2 plus 1. It uses this math. This is the old capacity. Old capacity is 10. So what happens? 15 plus 1 equal to 16. So what it starts? It will create another array of size 16. Size 16, and it will copy all the elements up to 10 and be ready for 11th element, and this will be get cleaned up. You see what I'm saying? And again, let's say this 16 also reached maximum. Then what happens? 16 into 3 divided by 2 plus 1. What happens? 16 into 3 is like 25. So the size of the array list will be increased from 16 to 25. Initially it was 10, it increased to 16 with using this formula, and again it increases to 25, and again it increases to some number. 25 into 3 by 2 is 75 by 2. 25 and 75 by 2 is like roughly around 30, 38, 38 plus 1, 39 size, something like that. Okay, like that it keep increases its size, array list. Okay, so instead of doing all this stuff, what they're suggesting is simple way. Let's see, we can try with array list al equal to new array list. You don't need to define the size, but you need to implement, because it is an util package. Util package must be. Okay, so it is giving some yellow is compilation. I mean, it's like a suggestion, something wrong. Okay, with the new Java there is a concept called generics, right? What you need to convey, what kind of objects that you are going to keep inside this list. Are you going to keep a strings? Are you going to keep the integers? Are you going to keep the double? Or are you going to keep some new object? Okay, so let's say I'll say I'm going to keep strings. You must say that. Okay, now how do you call this one? AL is an array list of type string. Okay, so let's say, how do I need to add values, right? AL dot add schema. You can keep adding, right? So now earlier what you in array list, what you used to do, I mean in arrays what you used to do like this, right? 0 index of 0 and keep some value here, right? So you don't need to do that, because collections provided a lot of functionalities with something like add, remove, all these functionalities. Okay, this is where practice required to remember, to understand the functionalities that has been there. Okay, then a1 dot whatever. Oh, it's a AL, sorry. Add of so you keep adding some values. Do you need to worry about the size? No, you don't need to worry about the size. So you added the values into an array list. Okay. So now your array list, so you can do whatever the operations, you can use this array list, you can pass it to different classes, you can pass it and you do the operations there and you do all the blah blah stuff. Okay. So that is good. And how do you extract the values from array list, right? There are three different ways you can do. One, simple for loop. Okay. For what we need to do? For int I is into 0, I is less than or equal to al dot size I plus plus. And then so there is functionality that is available already. You don't need to call like al dot length or blah blah blah. So this function will automatically return the size of the array. Okay, until then it will repeat. So now you can do CSYS OUT. How do you get the value? You add the value al dot add, right? So you get the value al dot get of whatever the index. What is the index? Whatever the I value is. So we got array index out of bound exception because -1. Okay. So that is one way. Second way, there is a concept called for each. For each. Okay, for each loop. Just like a for. So they enhanced this for loop such a way. So here there are some common things. You always initialize with 0 and you always check the size. You always increment until you finishes, you repeat this. That is the line, right? So why do Java thought like let's give some better functionality than this? They come up with called for each string that is there inside of this array list. So what they'll say is for each string s1 in al. That's it. SYS OUT for each loop. All you need to do is S1 for each loop using Shiva Santosh Kumar. So if you observe, right, this one does as good as this one. All it is, like this functionality has been moved into inside Java capabilities, I mean Java built-in, and this one, what it does, how do you read this in? For each string s1 in array list, okay, you need to segregate with colon. Okay, so from whatever the value from this array list, when you extract this array list, you will get one value, right? One value at a time, right? What kind of value you need to inform here for each string, and that value will be assigned to s1 and it will be displayed each time. That value will be assigned to s1 and assign it to, you need to display that. You can call it s1 or x1 blah blah 1, whatever you want to. Okay, all you need to display it. Okay, so that is another way. There is another way called iterator, using iterator interface. Okay, what we do with using iterator interface? For not iterator, So iterator is an interface, right? If you come back and look at iterator, and if you look at list interface, you will have list iterator, and list iterator can be used by ArrayList because ArrayList is a parent of ArrayList, right? So iterator, how it works, I'll tell you. Of type string, itr equal to, what is the array list we have? Al dot iterator. So when you say Al dot iterator, it will return an array iterator of type, it will return an iterator of type string. Okay, then what you can do is, this is the function, this is the predefined, like you don't need to much thinking also. While iterator dot has next element, then SYSOUT inside iterator. What you can do, itr dot next. So let's run this. You got inside iterator, same thing. So there are three different ways you can extract elements in from. There are three different ways you can extract elements from and collection. One is simple for each loop, simple for for loop, and another one is for each loop. The other one is iterator from the collection family. So how this iterator works, right? Yeah, it's okay. Let me. So what happens is, ArrayList has an implementation of iterator, right? So when you ask an ArrayList, so when you have an ArrayList, here we have this ArrayList of size 3, Siva, Kumar, Santosh. These three values are there, right? So when you create this iterator, when you create this ITR, you are conveying, it starts here, index. This iterator starts here. Okay. And then you are conveying the value that you need to extract is, a string. Okay. Then it starts from here and it checks ITR has next. Does it have any next value? Yes, it has. So it will return true. So it will go inside. And then ITR dot next extract this value. Okay. Next again loop continues. Does it have any value? Yes, it has value. Go and extract it. Does it have any value? Yes, extract it. Does it have any value? Nope. Stop. Same thing, whatever for each loop are different things too. Iterator also does, but it has some other additional functionalities apart from for each loop or for loop. We may not be using it here. Let's say, see, this is the has next is verifies whether that array list is empty or not, whether the array list is having a value or not. itr.next will give you whether the array list, what you are looking for, that value will be provided by itr next. So if you look at some other functionalities, itr dot equals and remove has next. So these are the 4 to 5 functionalities, additional functionalities are there. You can use them if required. Okay. let's do another example by taking from the console. Okay, ArrayList example 1 demo 2. So what I will do is simple, right? Our typical SOS, enter colors, enter color name. Okay, and then scan equal to new scanner of system dot in, and then scan dot next. What we can do is string color, or what we can do is we need to repeat it, right? So you want to take it from the console, you need to ask what is the I'm just thinking to loop it. How do we loop it? Yeah. Scan dot machine. Same thing, right? Same thing we did earlier for our SS. Content size. And you can take this one as for int I is 9 to 0, I is less than or equal to scan dot next -1 I plus plus. Then I'll keep asking the colors. Once I get the color, what I can do is here I'll define an ArrayList al equal to new ArrayList, now type string, and then you can directly add this value, right? Add dot I1 dot A1 dot add of scan dot next. Okay, and it will keep repeating and it will keep adding the values, right? So now we want to, let's say customer asked you to, like, next step is like, no, you have a list of colors, Then next thing is when somebody asks you what kind of color available or not, then you need to verify it and let the customer know. Okay, so what we can do is SIOT, what color looking for, then all you need to do is scan dot next. You will get the color what he enters. So all I need to do is if no, it doesn't help like that. String color scan dot next, and then if where do you need to check in the array list that you added, right? al dot, so as simple as that, right? They're using the functionality equals of color whatever user entered. If it is true, yes, we found it. Else we don't have it. See here, equals will say whether that element is or not. Another option is, you can say al dot contains whether this object is available or not. So another functionality that is available. Okay, what it does, whether it checks whether this object color is available in the array list or not, and then it will display it, right? So this is another way of doing it. And before that, let's do one more thing. At the end we'll list it out. Okay, for int, for each loop we can use, right? Al for each string in al, s1 s in al, sys out colors available, sorry, color name. See, okay, let's run this program. What the heck happened? Okay, enter the size. I'll say, I don't know much colors, man. I'll just add 4. Red, I don't know. Let me see. I don't think so. This is the problem. After int, something need to be done, I guess. 5 red. Okay, red, yellow, green, purple, what color is there? Blue. What color you're looking for, right? So I'm looking for, let's say, green. Yes, we found it, and then all the things are repeated, all the things has been displayed here, right? So let's say I'll just change the structure here a little bit. So we can simulate some scenarios. SOSOUT ArrayList display. Okay, let me try this. Enter 4, 3, color red, yellow, red. So list red, yellow. So whatever the inserted order, whatever the way you inserted red, yellow, red, whatever the red, yellow, same way you found the values. Same way the values has been displayed in the array list, stored in the array list. Okay. Now I want to, so you understand what are we trying to do? So you do a lot of around array list, like you can try, keep on trying, like, different things. And the main idea of trying out is like, I want to show you the difference between the list and set now. Now you understand how the array list works. Now I want to show you the difference between list and set. For list, I am taking array list. I'm taking array list as an example. For set, I'm taking as a hash set. Okay. In strings concept, for list I'm taking array list. For set, I'm taking HashSet, because say list and set are interfaces. We need to take some implementations, right? So in the same class, what we can do, okay, we defined array list, right? So we will do same thing for set. Okay, HashSet string hs equal to new HashSet. Okay, so here you got to know, and here you need to add hs dot add of, same thing, scan dot next. If you do scan dot next, it will cry. So I need to take this value here, scan dot next. String c equal to, we are keeping in both. Okay, apart from that we are doing nothing. We are keeping both in array list and HashSet, and we're trying to see the differences. Okay, this what color you are looking for, we don't need to. I just want to show you and some functionalities there. Okay, now you displayed here array list. Okay, and let me try to do HashSet as well. Hey, give me 1 second. My kid is woke up and is crying. Okay. Now you take the HashSet display, and here what you're going to do, HS, and then you're going to display the string again here as well. Okay. Same. Let's see couple of differences. Okay. I just ran the program, and it asking for size. I'll enter 4. Color is red, blue, yellow, green. ArrayList display. Okay, this guy. ArrayList display red, blue, yellow, green. Just want to create some nice feel this guy. Enter size 4, red, blue, green, yellow. ArrayList display red, blue, green, yellow. HashSet display red, green, blue, yellow. Okay, both are holding the values, 4 values. But in case of ArrayList, what happened? Whatever the way you inserted, first you inserted red, next blue, next green, next yellow. Same way the values has been stored. So that is the reason, same way you are able to extract it. Right? The way it stores, the way you can extract. So when it is storing, it's stored in the same way, whatever the way you inserted. But HashSet, what happens? HashSet, red, then green, then blue, and then yellow. So red, green, blue, yellow. For some reason, we'll discuss about that, why it is. But what we can conclude with this, an ordered collection, user of this interface has precise control over the elements is inserted. Okay, which means ordered based on index of the element inserted. Whatever the way you inserted, same way you can extract it. Okay, so here insertion will go in random order. It will go in random order. What does it mean is random order? So array list, this is the array list, and this is the hash set. Okay, array list. When you try to insert the first element, it will go here for sure. Okay, whatever it is. Next element, it will go to here. Next element, it will go to here. But in hash set, when you try to insert the first element, it may go here or it may go here. It will start here if you try to insert the first element. This is the first element, it goes here, and second element, it goes here. Third and fourth element, it goes here. Third element, it goes here. Right? The order has been not guaranteed. Why it sorted? Why the values has been moved around? Because of the way the logic that HashSet uses to insert the values. Okay, it uses hash code and it uses hash code technique to insert the values, which ArrayList doesn't use. It just goes with the index. So HashSet goes with the hash value. So it inserts the data in random order. Okay. Okay, next one, let's try. Enter size again 4. I'll say red, 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 red. ArrayList displayed size 4 and red, red, red 4. But HashSet only 1. What does it mean? What we can conclude that set doesn't allow duplicates. Set doesn't allow duplicates. List allows duplicate, doesn't allow duplicates. Inserts into random order. Okay, and last one, let me run 4 red null yellow null. Red null, yellow null, whatever you were inserted, ArrayList has been honored. But here second time null is not, you are not seeing, because it doesn't allow duplicates. Null values also same thing. So it allows as many null values as you want. It allows only one null value. Set allows only one null value. Null value is nothing but there is no value are there. Okay, it is not empty. It has a value null, but it has no meaning. Null means, okay, it's not empty. Okay, remember that. Okay, so these are the differences between list and set. Now let's see the differences between vector, array list and linked list. See, now we try to see the difference between list and set. What is the difference between list and set? Difference between list and set is list allows duplicates, set doesn't allow duplicates. List allows as many null values as you want, set allows only one null value. List allows list stores the data the way you inserted, ordered index, inserted in the order. Set doesn't allow, set inserts the data in random order. Okay, let's take another value in this. Yeah, we see the difference between these two, right? Let's see the difference between these three. In list family, what is the difference between array list, vector and linked list? Okay, basically in terms of implementation or the behavior is same because they are coming from the list family, but they have wrapped up with some functionality. So the differences we will see here: vector, array list, linked list. Vector is by default synchronized, which means it impacts on the performance. Okay, because as and when it is synchronized, you cannot update you cannot do multi parallel updates or parallel inserts, then it becomes slow. And array list and linked list are not synchronized. So in terms of performance, basically array list and linked list are better than vector. Okay, ordered insertion based on index, ordered insertion based on index, ordered insertion based on index, because all are following list family, right? Okay, so these are the differences mainly. If you ask me, search, insert, remove, which one performs better? How do you choose between, when do you choose array list, when do you choose vector, when do you choose linked list? If somebody asks you, these are the differences mainly. Vector is basically in a multi-threaded environment. If you want to go with a collection and you want a list collection, list family, then it's better to go with vector. Okay, but in terms of array list, when you want an array list, if you are doing less insertions and more search operations, which means like you keep thousands of elements in an array list in the application startup itself, and if you want to just verify the element is there or not, if you want to extract particular element from the 1,000 objects from the array list or not, those kind of concepts, those kind of scenarios, you may need to go for search scenarios. You need to go for array list. Array list is much better. One is better performance, three is worse performance. Okay, so in terms of search operation is once you have a collection of objects in your list, either in array list or linked list or vector, which one will be better for searching an element in that 1,000 list? In those cases, array list is better than linked list. But for insertion and removing, your linked list is much better. Linked list is much better in terms of performance than array list. Okay, so what happens is in linked list, right? Array list, we know, like it's a sequence bucket and it starts with some size. It will keep inserting, right? So here 1 2 3 4 5 inserted. This guy doesn't know about this guy, and he doesn't know about his neighbors, right? He doesn't know, this 2 is doesn't know about his neighbors, 1 is doesn't know whether he is the first element or not. He doesn't know anything, right? But in case of linked list, what happens is the values are not next to each other. Okay, in array list they are always next to each other, but they don't know about each of them. But in linked list, what happens? Let's say you keep Shiva here, the previous index is 0, the next value, let's say this one is starting 101, it will store 101 here, and let's say this guy's value is like 200, so it will store 200, so it will link it with this guy link it, and here Prasad, and this guy will store next guy's value 300, and 300 is here, and this guy knows this guy's value 400, let's say this 400, and Kumar, this is 500, this guy knows all the way this guy's address, this is 500, and this guy knows about this guy's address 600, 900, Kumar. Okay, so what happens in this case? You don't need a fixed size, right? If you define an array list, what happens? Basically it will take, initially it starts with size 10, right? So it needs back to back in the memory next to each other 10 blocks of memory is required. Okay, each block is element, then back to back, next to each other, they need to have this much of memory for sure. For array list, for linked list, not like that. One value can be sitting somewhere, another value can be sitting somewhere, another value is getting somewhere, but they just know each other's address, where they are sitting. They just know each other's address. Okay, so why it is better in terms of insertion and deletion? Why it is not better, right? So what happens is, let's say in array list, okay, I don't want to create another diagram. So let's say an array list, you'll have 1, 2, 3, 4, 5. Okay, I'll try to remove this element. Okay, what happens? It literally need to move all the elements on the left hand, right hand side to left hand side, because to fill this gap, right? So now 4 will be moved to fourth, third place, 5 will be moved for. Let's imagine it's a big size and you remove some value here. So it need to adjust everything for remove, or you try to insert some value suddenly and it need to adjust everything in the reverse way, right? The size of the array, as they are sitting next to each other, it need to adjust all the elements. Like, if you insert an element in between or in the beginning, each and every element need to be moved to the next location. Make sense? But in terms of linked list, let's say you remove this element. All you need to do is update this address here with 300. So the link will be established here. This will be disconnected. And this guy's address here. That's it. Right? You don't need to move the remaining elements. Whatever the elements staying there, they are staying as is. So that is the reason when you are inserting or when you are removing, linked list is far better. When you are inserting an element, when you are inserting an object into linked list, or when you are removing an element from the list, it's always good. Basically what happens is, like in simple way. In your application, if you have 1000 inserts and 50 search operations happens, okay, then go for linked list. Okay, let's say else 1000 deletes and 200 search operations, go for linked list. If you have only one time insertion, will have 1000 insertions one time, an application starting itself, okay, and 1000 search operations, go for array list. You have 100 inserts and 500 search operations, go for array list. Makes sense? A lot of people asking you in the interview, any interview, they will ask this question. Okay, when do you go for array list? When do you go for a list? Linked list? What is the difference between? That is the reason I try to capture as many differences as possible here. One thing I'm missing is hash map differences, the map differences. I'll try to capture and keep postponing from the last two classes. I'll do this batch. Okay. So, and then in ArrayList, if you know how much size you want, to always define the size of an ArrayList. Increasing the size of an ArrayList is costlier. I mean, this is one point you need to keep in mind is, if you know any of the size by any chance ahead of a time before while initializing itself, it's always good to initialize an ArrayList, because increasing the size of the ArrayList little costlier, because it need to copy array from one array to another array, right? You remember? Yeah. So vector is, if it is synchronized, what does it mean? If it is synchronized, by default it is thread safe, right? If it is synchronized multi-threading environment, it will be thread safe. It's array list not synchronized, not thread safe. Linked list not synchronized, not thread safe. Increase the size with double. How the increase the size with double? If initial size is 10, it will become 20 when it reaches maximum. Here, increase the size with half. If the initial size is 10, then it will make it 15 when it reaches maximum. I mean, whatever I explained the formula here, right? Old capacity, new capacity. Okay, so those are the main differences between linked list and array list. So if you really want me to type that keyword, I'll type it, but it doesn't make any difference for you. Okay, linked list. String ls equal to linked list. Okay, so what we can do, same thing, ls dot add c, and same thing you need to repeat it. Linked list display. So array list and linked list, are you seeing any difference? Red, red, blue, blue, yellow, red, red, blue, blue, yellow. You don't see the difference. But can you guys take an assignment to prove the performance? All by keeping these three lines, prove the performance. All you need to display the time. Before displaying, what you call the try to insert some value. Take an array list of size 100 or 1000 or 10,000, or keep repeating some values and increase the size, a very big size of array list or linked list. Okay, first thing. And then try to insert one value in between somewhere, and in array list as well as linked list. Before inserting, display the time like this. Before inserting, there is some functionality, timestamp display. Performance, no, not this one. I'll tell you one function. Give me 1 second. I'll have it handy. Recently in my project I did. Yeah. Who is this? It's a Spring one. Basically, all you may understand Java timer. Yeah, they are coming from third party, but I just want to see something will be there because we haven't discussed about third party, right? So there is no make sense. Come on now. Yeah, just look it around. Definitely you will have some timer, like just display the time before doing some operation, insert operation, and after displaying time, what is the how much time it take. All we want to prove is which one is better. You can see the difference. You by putting 4 to 5 values, you don't feel the difference. Okay, imagine if you have a bulk data in your array list, like thousands of records. See if you guys can prove it. I really appreciate that, and I'll update in my website as well with your name. Give it a try and prove it by putting some bulk data and or different ways you can search around. Okay, that is one thing. And next one is HashSet, TreeSet, linked HashSet. HashSet, TreeSet, linked HashSet. So are we clear with list? Do you guys have any doubts? Do you guys need any clarification? Okay. So HashSet, TreeSet, linked HashSet. Let's see how many people are staying. Nice. Good. Yeah, let's finish this piece and then we can. So we finished this piece and we need to see the set family and between HashSet, linked HashSet, TreeSet, right? What happens? So what we can do, let's introduce TreeSet as well here. Same values we're going to add. Let's repeat. Enter size 4, red, green, PQR, purple. So now see who displayed what. ArrayList display. Wait, 2, 3 times. Okay. ArrayList displays red, green, purple. Linked list also same way, red, green, purple, whatever the way inserted. HashSet, when it comes to HashSet, it eliminated the duplicate red. So red, green, purple. Okay. TreeSet, green, purple, red. TreeSet is, it also eliminated the duplicate, but the way HashSet inserted, the way TreeSet inserted is different. But as it is inserted in a random order that we know, linked HashSet, linked list or array list or vector will insert in the word the way you inserted. I mean displays the way you insert. But TreeSet is the way it got inserted and the way it displayed is little different. What it is, if you observe, it sorted the values. A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R. Even though you inserted red first, green next, purple, the way it displayed is green, purple and then red. So what does the difference between HashSet and TreeSet now? Both eliminates the duplicates, but HashSet goes the data in random order. TreeSet eliminates the duplicates. And one more difference, let's see one more. HashSet inserts the data in random order, so you get the data in random order. HashSet doesn't allow duplicates. When it comes to TreeSet, it also eliminates the duplicates. It inserts in sorting order. It insert in sorting order because in between set and TreeSet there is concept called sorted set also there, which will adopted by TreeSet. Okay, are you guys with me? So let's prove one more point as well. This in collection, trust me, whatever I'm explaining, these are all questions they will ask in interview. Not only that, when you are doing the program also, you should have this sense. 4. Okay, what I'll do, red, null, yellow, purple. So in terms of this piece, we are done. We don't need to discuss. So for time being, I'll just comment it. Okay, next time we discuss it. We are mainly focusing on HashSet and TreeSet. Okay. So when you enter null, both accept one null. Okay. And data will be in HashSet random order and TreeSet sequence order, and null will get the priority. Okay, let's run this program again. 4, enter size 4, sorry, purple, yellow, null, null. Same thing happened, both doesn't allow second duplicate, it eliminates the null also duplicate. There is one difference I want to prove it. Somebody will throw an error. Anyways, for now, okay, you understand what happens when you use TreeSet, when you use HashSet. HashSet is implemented using the hash table. It's okay, don't worry about it, we haven't discussed about hash table. TreeSet is implemented using tree structure, I mean basically sorting order. Okay, linked HashSet implemented as a hash table with linked list. Okay, and then performance wise, O of 1, O of log of n, O of 1. I'll explain this later. Okay, for now just ignore it. Just the performance wise, you just remember, if somebody asks what is the performance of HashSet, just you tell them O of 1. Okay, for any operations. Okay, so the data will go in random order. It will be TreeSet, it will be sorted the items in sorting order, but need to implement comparable comparator interface to execute sorting. We haven't discussed about comparable and comparator. In the next class we'll discuss, but for now it will do the sorting. Okay, linked HashSet, this is the difference. Insertion order, generally set is random order, but linked list who implemented set, but it has its own behavior which is goes with insertion order, just like ArrayList or linked list, but HashSet goes random, TreeSet goes sorting order. all are not thread safe. Speed wise, HashSet is speed and better speed, and then linked HashSet and TreeSet. TreeSet, why it is slow? Because every time you insert a value, it need to check, because it need to sort it, right? Who comes first? Here, when you insert purple, it need to check, oh, is there any elements? No elements. Okay, let me insert. Then it comes yellow. Oh, yellow comes first or purple comes first? It need to check again before inserting into TreeSet. And then null. Oh, null. Oh, null comes first, so I need to give null now. See, that operation, it always need to do each element when you insert. So TreeSet is very costly. But if if you encounter any situation where you want the data in sorting order, it always good to go for TreeSet. Okay, so speed wise, HashSet is better. TreeSet is linked HashSet is second. TreeSet is third. Yeah, this is not enabled table to produce. I don't know. Allows only one null. HashSet allows only one null, right? If you try to insert another null, it will overwrite. Same thing. Not allowed. Throws null pointer exception. I don't know why it is not throwing. I'll just check once again. Allows only one null, only null. Okay, HashSet is implemented using hash table, equals method for comparison. HashSet uses equals method for comparison. TreeSet uses compare to for ordering. This one we haven't discussed. We'll discuss when we go for comparator. And linked set uses equals for comparison. Okay. Where the hell it is not? TreeSet. Why it is not? Because it always try to compare and it throws an error. Because it is the string, it is not doing it. Yeah, keep that point. I'll prove it tomorrow. Yeah, that's it for today. Tomorrow we'll discuss about. I don't think so. I can take the class one more class.